polynomials. We have several patterns in factorization of polynomials, and we'll be dealing with 7 patterns. But for now, we will just concentrate on patterns number 1 and number 2. And here are the terms to remember in factorization of polynomials. First, factors. What are factors? If P, Q, and R are polynomials such that P is equal to Q times R, then Q and R are the factors of the polynomial P. So, these polynomials multiplied together to produce the polynomial P are the factors of P. Number 2, prime polynomials. A prime polynomial, like a prime number, is it has no other factor except 1 and itself, and completely factored form. A polynomial expressed as a product of prime polynomials. Example, 6y squared minus 12y is expressed as 6y times y minus 2. The factors 6y and y minus 2 have no other factors except 1 and itself. So this is a completely factored form of a polynomial. Then number 4, we have prime factorization. Prime factorization is the process of factoring a polynomial completely as a product of prime factors. So here we have expressed the polynomial as a product of prime factors, so we have done prime factorization. Now let's go to pattern number 1. So the first pattern is common monomial factor, or you have to get the common monomial factor of a given polynomial. Example, the pattern is AB plus AC is equal to A times B plus C. We get the common factor A for both terms in the polynomial, and then remove that common factor and make it the first factor. So A is the first factor, and the second factor is you derive that by dividing out A from the given polynomial. So what will be left is B and C. So B plus C is the second factor. So in general, you just get the greatest common factor of the two terms, or the greatest number and variable that can divide the two terms. That will be your common monomial factor. Example number 1, xy plus xz. So the common monomial factor is x. Remove the x from the two terms, and then what you will have left is y plus z. That will be the second factor. Okay. If you look at this first example, we can model it by using the area model. And xy is an area representing a rectangle here with one side as x and one side as y. And then xz is another area or another rectangle where one side is x and the other side is z. So you see that there is a common side which is x. Here there is an x, and here there is another x. So that is the common monomial. Then take out the common monomial, you have x. What will be left is y plus z. Actually, this one represents the area of the rectangle. So the area of the rectangle is xy plus xz. This is xy and this is xz. And then when we factor, we are actually getting the dimensions of the rectangle. So the dimensions are the length and the width. The length is y plus z and the width is x. So the factors are width times length or length times width. It can be interchanged. Okay, number 2. ax minus ay plus az. Again, it's very plain to see which is the common monomial factor because it's very obvious. So you simply get a out of the picture, and then what is left is x minus y plus z, and that is the second factor. Okay, in number 3, we have 3x squared y cubed plus 6x y squared. It is not easy to detect the common monomial factor at first glance, but you have to get the GCF of the terms of the polynomial, and that will be the first factor or the common monomial factor. What is the GCF? It is the greatest number, and this time with the variable that can divide all of the terms or both terms here. So we have 3 and 6. Which can divide both? Which number can divide both? So we have 3. 3 can divide 3 and 3 can divide 6. And then we have x squared and x. So what can divide x squared and x? It is x. So you have to choose the power which is the least power of that variable that is common to both of the terms. And then we have y cubed and y squared. So the least power of y is y squared. Then you use this as your divisor, and then divide out each term of your polynomial by the first factor, and it will give you the second factor. So you have 3x squared y cubed divided by 3xy squared. So we have x squared divided by x and y cubed divided by y squared plus 6 divided by 3, and then x divided by x, that cancels, and then y squared divided by y squared, also they cancel. So this is your second factor, and that's the answer, completely factored form. Number 4, we have a trinomial, and then you first look at the numerical coefficients of the trinomial. So we have 5, negative 10, and 20. And then think of the number, the greatest common factor of 5, negative 10, and 20. So it is 5 because 5 can divide itself, 10, and 20. Okay. Then you look at the common variables. We have x cubed, x squared, and x cubed, and pick out the lowest power of x, which is x squared. And then y cubed is also common, y cubed, and y squared. And the least power of y is y squared. So this is now your common monomial factor. Then use this as the divisor to divide all of the terms here. So we will divide mentally. And we have x, y minus 10 divided by 5, 2. Then we have x and x squared and x squared cancels. And then y cubed and y squared. So we have 2y. Then plus, then 20 divided by 5 is 4. Then x cubed divided by x squared is x. And then y squared divided by y squared is 1. So that cancels. And this is your second factor. This is now in the completely factored form. Now let's go to the second factorization pattern. The second factorization pattern is factoring the difference of two squares. We have a squared minus b squared, which is equal to a plus b times a minus b. Remember the special products where we have the product of the sum and difference of the same two terms, and we get this as the answer. Now we will reverse the order, and you start from the product and then you get the factors. So following this formula, we have example number 1. 36 is a perfect square, so this stands for your a squared. And then the b squared is this one, another perfect square, 25y squared. So this is your b squared. So what we'll do is we'll just get the square root of this one and square root of this one to get the a and the b. So the a is equal to the square root of this, so we have 6x plus the square root of this is 5y. And then the other factor is 6x minus 5y. And that's the answer. Number 2, we have 16a squared minus 9b squared. Both are perfect squares. So square root of 16, 4. 4a plus square root of 9, 3b times 4a minus 3b. Okay. Actually, you can write that in reverse order. And then number 3, we have 16a to the 4th. So square root of 16a to the 4th is 4a squared plus square root of b to the 4th is b squared. Then the second factor is just copy 4a squared then minus b squared. The first factor is a prime factor, but the second factor is still factorable because you have a perfect square and another perfect square. So it's a difference of two squares. So we can still factor that. So we have a second step. Copy the first factor and then factor the second one. 4a squared plus b squared times square root of 4a squared 2a plus b 2a minus b. So you have 3 factors, and this is now in completely factored form. Now, you have to practice this, memorize the pattern, and apply. So, let's try the following. Factor the following polynomials completely. Number 1. So, this is an example where you can get the common monomial factor. And you have the numbers 3 and 18, the numerical coefficients. The GCF of that is 3. So we get 3. And then the least power of x is x squared. Since there is no y here, it's not a common factor. So this is your common monomial factor. And then the next factor is you divide this by 3x squared. So you have x minus negative 18 divided by 3 is negative 6. X squared divided by x squared, that cancels. And you have y to the 4th. Okay, that's the answer. Number 2, observe the terms and the numerical coefficients 24, 18, and negative 6. What is the GCF? So negative 6 can divide 18 and 24, or simply the number 6. So we get 6. And then m is common to all, but the least power of m is m squared. And then n is also common, but the least power is n. So this is the first factor, and the second factor is 24 m to the 4th n squared divided by 6 m squared n. 24 divided by 6 is equal to 4 m squared n plus 18 divided by 6, 3 m cubed divided by m squared is m, n squared divided by n is n, and then minus 6 divided by 6 is 1, m squared divided by m squared is 1, and n divided by n is 1. So what is left? Minus 1. Okay. Number 3. We have the difference of two perfect squares. Square root of 4m squared, 2m, plus square root of 9n squared, 3n, times 2m minus 3n. That's the answer. And number 4, square root of 16, 4, x, plus square root of this, y, over 2, 4x minus y over 2. That's the answer. So for our next video, we will have pattern number 3 and number 4. And I hope you will follow the videos and complete the patterns up to pattern number 7, because you will really benefit from having this skill of factorization. It will be very helpful in solving problems later on, especially in solving equations. Please like, share, and subscribe to this channel by clicking the button below. Thanks for watching, and bye-bye.